Hello and welcome to the second big part of this implementation, training the brains. So we have just smashed part 1, creating the brains, and now we're going to tackle part 2, training the brains. So this training implementation will be broken down into 2 big steps. First step will be to update the weights of the neural network of the discriminator, and then the second big step will be to update the weights of the neural network of the generator. And then if we want to break down this process into some more steps, well, that's how it goes. In the first big step, updating the weights of the discriminator, we will want to train the discriminator to see, to understand what's real and what's fake. So we will first train it by giving it a real image, and we will set the target to 1 because 1 means that the image is accepted. And then we'll do another training by giving it this time a fake image and setting this time the target to 0 because 0 means that the image is not accepted. So this first big step can be broken down into 2 sub-steps. First, training the discriminator with a real image, and then training the discriminator with a fake image. And this fake image will be, of course, a fake image created by the generator. And then, in the second big step of the training, that is about updating the weights of the neural network of the generator, well, we'll take the fake image again, which will be in one step of the loop. Then we'll feed this fake image into the discriminator to get the output, which will be a value between 0 and 1, the discriminating value. But then we will set a new target to 1. The target will be equal to 1, always, and we'll compute the loss between the output of the discriminator, the value between 0 and 1, and this target always equal to 1. Then be careful, that's the key thing to understand. We'll backpropagate this error, not back inside the discriminator, but back inside the generator. That's the key thing to understand. The error is the error between the prediction of the discriminator and the target equal to 1, but we will backpropagate this error back inside the neural network of the generator. And then once we do that, we'll apply stochastic gradient descent to update the weight of the neural network of the generator. Alright, so we have given a teaser of what's going to happen in the second big phase, training the brains. So let's tackle the second big phase and let's start right now. Alright, so we have to start by getting a criterion that will measure the error of prediction that will be a value between 0 and 1, because that will be the prediction of the discriminator, the discriminating number between 0 and 1, and a ground truth that will only be 0 or 1. 0 means fake and 1 means real. So let's do this. That's our first step. We create a criterion object that will be an object of the BCE loss. So if we go to the PyTorch documentation, we can see that the BCE loss is actually given by this formula. And so this is a special kind of loss perfect to train the adversarial networks. And BCE means binary cross entropy. So that's the loss we'll be using for our DC GANs, but we see that it is also used for autoencoders. But the most important thing is that the target should be numbers between 0 and 1, and that will be the case for our DC GANs because the targets will either be 0 when we want to train the discriminator to recognize a fake image, or 1 when we train the discriminator to recognize a real image. So BC loss, and then we just need some parentheses. Alright, so perfect, we have our criterion, and now we need 2 optimizers. One optimizer for the generator, and one optimizer for the discriminator. So we'll start with the optimizer of the discriminator, and this time we're not going to get it from NN, the NN module, but if we have a look again at our libraries that we imported, well, as you can see here, we imported torch.optim, and we gave it the shortcut name optim to simplify, but that's from which we will import our optimizer object. So here we go, optimizer D equals optim dot, and we'll get the Atom optimizer, which is a highly advanced optimizer for stochastic gradient descent. Okay? And now this time we have to input some arguments. The first argument we need to input are the parameters of our neural network, the one of the discriminator, and to get them we're going to take our neural network object of the discriminator that we called netD. So netD, and then dot, and then we get the parameters this way with some parentheses. Then we need to specify a learning rate, and the argument for that is LR, and we'll choose a value of 0.0002. And then as a third argument, we need to specify the betas parameters, and we're going to input them this way. The name of the argument is betas, and it's actually a couple of two values that we have to choose. And if we go to the PyTorch documentation again, well, we see that for this atom optimizer, that these betas are actually coefficients used for computing running averages of gradient and its square. So we're just going to pick two values now, again coming from experimentation, and we'll choose 0.5 and 0.999. Great, perfect. We have the optimizer of the discriminator, and now let's get the optimizer of the generator. So since we're going to have the same parameters, the same learning rate and the same betas, we simply need to change the name of the optimizer, and of course we're going to call the optimizer of the generator optimizer G, which will also be an atom optimizer with the same parameters, except of course for the parameters of the neural network. So here we just need to replace netD by netG. And perfect, now we have the criterion attached to the BCE loss, the optimizer of the discriminator, and the optimizer of the generator. And that's good news, because basically we're ready to start the big loop of the training. That is, the loop over the different epochs. So we're going to have 25 epoch, and therefore this loop is simply going to be for epoch in range 25 and colon. And this way, the epochs will go from 0 to 24. We'll have 25 epochs. You're welcome to try more epochs if you want to try to have some even better images, but I can tell you that already with 25 epochs, we'll get some great images. And also what's important to understand is that in each of these 25 epochs, we'll go through all the images of the dataset. We'll go through all the images of the dataset 25 times. All right? So now we're directly going to start with a new for loop that, if you've listened to the last sentence I've just said, is going to be the loop that will go through all the images of the dataset. Therefore, the second for loop is going to be for I, which will just be the index of the loop, and then data that will contain a mini batch of images. We will go through all the images of the dataset, mini batch by mini batch. That's exactly what it means, and data will be one of these mini batches. So we're breaking the data, the whole data set of all the images, into mini batches, and data will be each of these different mini batches. And so now, to get these different mini batches, we're going to use data loader, and we're going to use the enumerate function to get these separate mini batches of the data set. And so inside enumerate, we have to input our data loader, which will get us the mini batches. But then we also have to specify where the index of the loop is going to start from. That is, where I is going to start from, and I will start from 0. So I'm just adding 0 here. And there we go. We are ready to start the big two steps of the training. So we'll do these big two steps in two separate tutorials. The next one will be about updating the weights of the neural network of the discriminator. Then the next tutorial after that will be about the second big step, about the updates of the weights of the neural network of the generator. And then we'll have the last, final, exciting tutorial to print the losses, save the real images, save the fake images, and watch the final results. So be ready for all this, and until then, enjoy computer vision!